Welcome to the AMU tutorial video lecture series. This is the first lecture of the course Dam Engineering. In this course, we will be discussing about arch dams, buttress dams, and earthen dams and their design analysis. Now, before going to the details of arch dams, first we have to discuss about what is a dam. A dam is an obstruction or a barrier that is built across a stream or a river. Now, there may be different situations where we need to build a barrier across the river. There may be reasons where we need to store water. Sometimes we need to have to generate electricity. Sometimes we require to control floods, or for irrigation purpose. There may be several purpose or collective all these purposes. So for to serve this purpose, we need to store water. Okay, so to store the water, to collect the water at some place, or to create a reservoir, we need to build a barrier across the river. Okay, so that barrier is known as a dam. Now suppose this is a river channel and the water is flowing from this direction to this direction. Okay, and suppose this is a section of this river, an arbitrary section, and this is the depth. Now suppose there are some villages or cities or people are living here, suppose. Okay, and there may be some season or some period where the flood causes a serious disruption to the life and property for the people living across here, or the people across here needs to irrigate their lands. Okay, or maybe other reason. So we need to store water. If suppose this is a flood situation, so we need to cut the water flow from this side to this side. So for that we need to build a dam, a barrier, and that barrier is known as a dam, right? Like this. Now I'm building a dam over here. What will happen? The water will rise. Now the water level will not be up to this mark. This may rise. This may rise like this. Earlier this was this level. Now it's up to this level. Okay. So water may rise. Now, due to this also, what will happen? This increase in volume of water will spread. Okay, it will spread, and we have to evacuate all these places where the water will go submerged. Okay, so this pool of water, is known as a reservoir. Okay, this side of a dam is known as its upstream, and this is known as the downstream. Okay, upstream and downstream, and this is upstream. Okay, now there are several types of dams. There may be gravity dams, there are arch dams, there are earthen dams, there are rock fill dams, there are steel dams, there are concrete dams, masonry dams. There are so many types of dams. So the functioning, the construction, the mechanism of load transfer are different in different types of dams. So in this present course, we will be discussing about the arch dams in particular. Okay. Now, arch dam is a dam which is curved in plan. Okay. Now suppose if you have already studied about the gravity dam, so you must have learned that the section of a gravity dam is like this. Okay, it's something like this. If you draw a structure, a view of a dam, a typical gravity dam, so it will be like this. Okay, it will be something like this. So the top view is like this. Okay, the top view is like this, and this is the section. Okay? This is the section. This is a typical example of a gravity dam. Okay, a gravity dam. What is a gravity dam? Just to give you a brief knowledge about gravity dam. A gravity dam is a type of dam where the stabilizing forces are only the weight of the dam. Okay, this is a gravity dam where the stabilizing forces are only the weight of a dam. Okay, so this is the typical section. Now there is a slight difference in arch dam. What is arch dam? In plan, the dam is like this. In plan, it is an arch. It is an arch. Okay, and in section, a section is typically just like similar to the gravity dam, but it is arch like this. Okay, like this. In a arch dam. Now, unlike gravity dam, the load transfer, the stability is actually achieved by the arch action. The arch action, not by the weight of the dam, but the arch action. And in this type of dam, in arch dams, what will happen? Transmitting the major portion of the load is to the abutments or the valley sides rather than to the floor of the valley, and the remaining part of the load is transferred by the cantilever action. Okay, also, since in gravity dam the main stabilizing force is the weight of the dam, so the section of a gravity dam is very massive. The weight of the dam is very high. It is a massive dam. But since the stabilizing force in arch dam is not the weight of the dam, so the section of the arch dam may be lesser as comparison to the gravity dam. Okay, it is less thick. Okay, the main load transfer mechanism is through the arch action and the cantilever action. Okay, to the foundation. And since this is not so massive dam, so the base width is lesser as compared to the gravity dam, so the problem of uplift force is also very negligible in this case. Okay, in case of arch dams. Now I will show you some typical examples. A practical, a live photo. This is an arch dam. Okay, so you can very well see in a plan it is curved. Okay, whereas in case of a gravity dam it's like this, and you can very well see this is an arch dam and the plan is like curved. Okay, it's curved plan. It's a curved plan. Okay, so this is the upstream and this is the downstream. Okay, another is this. So you can, okay, I will delete this. Yes. So this is the upstream portion and this is the downstream portion. You can see this is the road and this is the arch, a curved in plan. So this is a arch dam. Okay, I'll show you another example. Look how beautiful. So arch dam is basically preferred where the narrow gorge is there or a U-shaped gorge is there. So this is a narrow gorge. You can see here this is the arch dam, a curved. Okay, this is a curved part. This is downstream section. Okay, example of an arch dam. Okay, another view. So up till here we have discussed the plan or the basic definition of an arch dam. Now we will be focusing about the arch geometry and its profile. Okay. Now in an arch dam, the horizontal component of arch thrust must be transferred into the abutment. Okay. Now what will happen? What does it mean? Suppose this is an abutment. Okay, I'll show you the figure. Suppose this is the abutment. Okay, and this is the arch ring. Okay, the arch, and these are the abutments. Now in case of arch dam, since the main stability is due to the thrust into the arch, into the abutment, so that the abutment should be very strong. It should not yield. Okay, so there should not be any yielding of the abutment. If there is a slight yielding of abutment, then what will happen? The dam will fail. So there should not be any yielding of abutment. Okay, so in order to satisfy this, there should not be any yielding. We have to ensure that the horizontal component, the horizontal component the horizontal component of arch action of this thrust should be at the safe angle. Okay, should be at the safe angle. So look at here, this is the abutment. Okay, this is the thrust. Okay, this is the thrust, and suppose this is the line of tangent. This is the line of tangent. Okay, this is approximately the contour lines of a sound rock, and the angle between this is the beta angle, that is the approach. Okay, this is the beta. Okay, here 2 theta is the central angle of an arch. It is the central angle of an arch. Okay, r is the radius. Okay, here it is the upstream, here it is the downstream. Okay, radial line means along the radius. So you can very well see here, and if this is the zone of thrust action, so it should be at in a range of 60° approximately. Okay, this should be around 60° for a better result, for a better support. Okay, in this case there will not be any yielding. Okay. And the range of this angle beta should be 30°. Okay, so the geometry of this arch should be like this, so that there should not be any yielding of abutment. Okay, let me clear all this. Now horizontal thrust should distribute along the included angle of 60°. Okay, so in the previous slide this is the included angle of 60°. Okay, so horizontal thrust should be along this. Okay, and abutment entry angle should be between 45° to 30°. Okay, this should be the abutment entry angle. Okay. Now, in a perfectly symmetrical valley, the minimum dam volume would occur when the central angle 2 theta is equal to 133 degree. Okay, 133 degree. But practically, it is very difficult to get this angle. It is very difficult. So there is a safe range. It should be around 270 degree to 110 degree. Okay, this is the range of this angle. But theoretically, the value of 2 theta, the central angle, should be this. Okay. Now there are different types of arch dams. There are constant radius arch dams. The meaning of constant radius arch dam is, suppose uh, this is an arch, okay, and the radius of this arch is say r, and this is the say center O, okay, and suppose this is at the top, okay, this radius r is say at the top here, okay, this is the section, and if you see, this is the top, okay, and at the top the radius is say r, okay, this much, this is the curve. Now say some z depth below at here, the radius of this arch, if it is say r, again, if the radius here is same to the radius here, okay, if the radius at the top is say r and radius at z unit below is also r, is also same, okay, and again at this level, say z2 level, it is again the radius of this arch is again say r. So at all the level, at all the elevations, if the radius is same, okay, if the radius is same, then this is known as constant radius arch dam, okay, constant radius arch dam, okay, have you understood? Now what will happen, suppose this is the center, okay, this is the center. Remember this, that the center will lie in a same horizontal, same vertical line, not horizontal but same vertical line, okay, the center lie on a same vertical line, but all these center will be at different levels, okay, the levels will be different. So this is of the say, top center, this is something, some z meter below, below. So all these centers will lie at a same vertical line, but at the different elevations, okay. Also, what happened, in order to vary the thickness of this section, vary the thickness, the angle, the central angle will change, okay, the central angle will change. As you can see here, the central angle of the topmost arch is from here to here, and the central angle of this arch is from here to here. So in order to vary the thickness, the central angle may change, okay, but the radius throughout the elevation, throughout at all elevation is same, okay. So this is an example of constant radius arch dam, okay. Another example is variable radius arch dam. So contrary to the previous example, in this case what will happen, the radius will vary at all the elevations, the radius will vary. Suppose this is the top and the radius here is say, okay, is say here, say like this, say r1, Again here, now the radius will vary. Okay, earlier it was, so if the radius will vary, then the curvature will be different. Curvature will be different. Okay, so radius will vary. So due to this varying radius, what will happen? The upstream face of the dam will be like this, will not be straight as in the previous example. You can very well see the in constant radius arch dam, since the radius are same, so the upstream phase, this is the upstream phase, so upstream phase is vertical, and since the angle, the central angle is changing, so the thickness is more. Okay, at near the bottom, and thickness is less near the top. Okay, but in variable radius arch dam, since the radius is changing, so what will happen? Due to this change in radius, the upstream face is not vertical, it is like this, it is curved, it is also curved. Okay, it is also curved. It is something like a cupola profile. This is known as cupola profile. Cupola profile means that when there is curvature in plan as well as in elevation. Okay, when the dam is curved in section and also in plan. Okay, so this is cupola profile. So in variable radius arch dam, the cupola profile is uh, formed. Okay, so this is a variable radius arch dam. Okay, in constant angle arch dam, the central angle is constant, is does not change. Okay, the central angle does not change, so the angle is same. Okay, if the angle at all the elevations remains same, remain constant, then this type of dam is known as constant angle arch dam. Okay, so these are the three types of arch dams: constant radius arch dam, variable radius arch dam, and constant angle arch dam. Now if we take the central angle to be 133 degree 34 minutes, then this is the most economical. This is the most economical. Okay. We will be discussing later on why this is the most economical profile. Okay, so in this lecture I have discussed about the very basic of dams and arch dams in general, in particular, and I have also discussed the types of dams. I have tried to simplify the lecture in this in this basic categories, so that the learning may be easy. Okay, so if there is any question regarding this topic, regarding the topics that I have covered in this lecture, then you can very well post your questions in the comments. Okay, so do post your questions only in the comments. Okay, so in that way it will be very easy to answer. Okay, and also all the questions will be at the same platform. Okay, so anyone can, if I answer a question in this box, then everyone will get the answer. Okay, so try to post the comments, your questions in the comments, and also you have to download the course materials. Okay, unit wise course material, and the slideshow that I am, the very same slideshow that I am using in this video lecture. I'll be uploading all those course material and slideshow on this website. Okay, and questions you have to post in the comments. Okay, so I'll be looking forward to hear from you, hear your feedback, and I'll be posting subsequent lectures in great detail about the arch dams, about the buttress dam, and about the earthen dams. So keep watching and goodbye. Thank you.